All right, let's jump right into this explainer. Welcome back, everyone. Today, we are exploring a truly fascinating piece of technology that is fundamentally changing how secure organizations write software. We're getting into the very essence of G-coder technology for programmers. This is a system designed from the ground up as the ultimate defense-grade AI coding assistant. This isn't just another flashy autocomplete tool you download on a whim. This is a highly secure blueprint for autonomous engineering that respects strict confidentiality.
So think about it for a second. We all absolutely love the speed of AI code generation, right? But there is a massive, often ignored security risk running in the background. Modern vibe coding might feel incredibly fast and fluent, but when you're using standard AI tools, you are very often sending your highly sensitive, proprietary source code directly out to external models in the cloud. And listen, for a regulated enterprise or a defense contractor, your source code leaving your perimeter is the exact risk that must absolutely be avoided at all costs. Here is our roadmap for today. We'll cover the problem of unsafe AI coding, the architecture and 4 principles, the Interactive Agent Council, 2-stage RAG security, how G-coder stacks up against competitors, and finally, service levels and integration.
Okay, Section 1, the problem of unsafe AI coding. Let's get right into it.
First things first, G-coder isn't built by some weekend project consumer startup. It's actually the product of AlfaCan Defense Group Limited. With their official UK registration number 17062207, established in England and Wales, this is a company with serious defense-grade DNA. Their status as a defense group means that their entire secure development architecture is dictated by non-negotiable safety and data isolation invariants specifically for pros. They completely understand that for professional engineers, security just cannot be an afterthought. The crucial thing to understand here is what we call the vibe coding threat. Look, AI models often generate code that looks incredibly plausible to the human eye. It reads great, but underneath, it's often highly flawed. The AI hallucinates APIs that literally don't exist. It completely misses crucial edge cases. More alarmingly, because standard models optimize for just sounding plausible rather than adhering to a strict threat model, they routinely introduce OWASP and CWE top 25 vulnerabilities. We're talking injection flaws, broken access control, insecure deserialization, the whole shebang. And the absolute worst part, to get this flawed code, your proprietary data just left your secure perimeter.
Section 2, Architecture and 4 Principles. So how do we fix this? Well, G-coder operates on 4 core principles that works together flawlessly. First, we have air gap by default, meaning your code is isolated. It never leaves the network. Second, the Observable Agent Council, which makes the AI's reasoning entirely visible to you. Third, doctrine grounding via RAG, ensuring the AI follows your strict security standards. And fourth, human-on-the-loop autonomy, meaning literally no code is ever applied without a human explicitly saying so. Together, these form just an unbreakable security posture. And here is a wild, surprising economic advantage. $0. That is the server compute costs for running the editor, which perfectly demonstrates why G-coder is miles better than cloud-based solutions economically. Because G-coder operates as a branded desktop IDE, it's actually a fork of VS Code. Locally on the programmer's PC, all the heavy lifting of editing, terminal operations, and building runs entirely locally. You're not paying massive cloud compute bills for a virtual workspace. That translates to a highly scalable system that achieves an amazing 85% gross margin for the provider.
Moving on to Section 3, Interactive Agent Council.
Real quick, before we meet the council, we absolutely have to define this critical term. Why do we even need an air gap? Well, an air gap is a strict security boundary. In the world of G-coder, it is a rock-solid contractual guarantee that your client source code never reaches an external AI API without explicit sanitized user opt-in. This is exactly how G-coder ensures total data isolation. If a client declines external validation, they are running a completely isolated local AI contour. Your secrets remain 100% yours.
Now, instead of a black box AI that just magically spits out code, G-coder literally convenes a meeting. Think of it like a virtual boardroom. First, the orchestrator, which is powered by a Gemma 4 model, plans out the task. Then the generator actually writes the code. Next, the reviewer critiques it for security flaws. And finally, an optional validator checks it over. The absolute best part of this? You, the human engineer, are watching this deliberation turn by turn right in the chat. You can interrupt, ask, hey, why are you doing it this way? Or completely steer the direction before a single line of code is applied. Which brings us to a crucial point, summarized by this single word, действуй, which roughly translates to approve or act.
This is the strict human-on-the-loop gate. In Gcoder, absolutely no change is applied or deployed autonomously. The human operator's explicit, spoken approval in the chat serves as the unbreakable audit trail. Actually, scratch that, it's more like a mandatory checkpoint. If it's a highly critical system change, it will never auto-apply. This guarantees the human is always the ultimate supervisor.
All right, Section 4, two-stage RAG security.
We know the Agent Council reviews the code, but how exactly do they know what's secure? Well, the reviewer agent isn't just relying on generic, out-of-the-box AI training. It uses a strict two-stage retrieval augmented generation, or RAG process, to protect the code. First, a by-encoder retrieves the company's specific secure coding doctrine. Then, a cross-encoder re-ranks those rules for relevance. Finally, the AI strictly reviews the generated code against the OISP and CWE top 25 vulnerabilities. Guys, it is literally like having a principal security engineer enforcing AlfaCan security standards on every single line of code you write.
Oh, and the system actually learns over time. Through a tightly governed debrief loop after a verified coding outcome, Gcoder distills lessons right back into the secure coding doctrine index. But here is the genius part. It only writes back anonymized, fully sanitized patterns. It never, ever stores the client's raw proprietary source code in the learning loop. This means the system continuously improves and gets smarter while still maintaining that absolute ironclad data privacy guarantee.
Next up, Section 5, Gcoder versus competitors.
Let's get to the moment of truth and look at the massive advantages of Gcoder over mainstream competitors like GitHub Copilot and Cursor. When it comes to the data boundary, Copilot and Cursor are streaming your data straight to the cloud, whereas Gcoder maintains a strict air gap by default. Execution. The competitors often just auto-apply or semi-auto-apply changes, while Gcoder demands that explicit DistVoy, human-on-the-loop audit trail. And for editor compute, cloud IDEs carry absolutely ruinous costs at scale, but Gcoder operates locally at zero server cost. It is a fundamental paradigm shift in privacy, execution control, and cost.
Finally, Section 6, service levels and integration.
A crucial point here is the metered pricing structure, which is completely transparent for enterprise scaling. Gcoder works across 4 clearly defined S levels. You've got S1 starting at $25 a month for light AI use, and that scales all the way up to S4 at $100 a month for maximum AI intensity. The beauty of this is that it's uncapped, meaning a team is never hard-blocked mid-flight. Any usage beyond a tier is simply billed as overage. This structure is exactly what allows AlfaCan to maintain that highly efficient economic model we talked about earlier. And for existing users of Guardian Cloud, Gcoder integrates flawlessly. If you're already a customer, Gcoder provides a net allowance of included S1 seats that scales directly with your cloud tier. So for example, an enterprise tier gets an effectively uncapped allowance of baseline seats. This creates an incredibly seamless, unified, and strictly secure ecosystem for teams to work inside. No dealing with fragmented billing or juggling multiple disconnected vendors. Which brings us to our final thought for today. After seeing the strict air gaps, the completely observable agent councils, and the rigorous two-stage RAG security validations, I really want to leave you with this question. Do you truly know where your proprietary source code goes when you use standard AI tools? Because if you can't confidently answer that, it might just be time to look at an architecture that was actually built by a security company. Thank you so much for joining me on this explainer, and I highly encourage you to keep questioning the tools you trust with your most valuable data.